So on the bench, we have the beginnings of an IMSAI 8080 build. This is a mini IMSAI 8080 front panel that was designed by Don Caprio back in 2014. I've had this board partially assembled for quite a while. I've been working on reorganizing the lab, and I finally found the switches for this board. I've got the momentary up or down over here. And along here, of course, are just toggle up and down. And I don't remember whether I've got the colors correct here or not, whether it should be blue on the outside. But I have enough of these to, get the colors in there I want. I recently, in the last year, ordered a couple of IMSAI CPU MPU-A clone cards, which is what we have right here. And notice there's no silk screen, there's no markings, there's just a board. Actually got two of them. I like to have a second board as a reference if I can. Got the manual here that goes through the construction, and towards the back there is the parts list, and it's a pretty standard set of parts. An 8216, an 8212, an 8080 processor, 7805. I mean, it's pretty standard stuff. Looks like we need a bunch of 1K ohm resistors, some 4.7K. Remaining parts, 18 megahertz crystal, which I've got. A photograph of the board, and then we actually have the parts where they go on the board. Holding it upside down. So pin 1 is in the lower right on the devices, which is interesting. It looks to me like pin 1 on the 8080 is up in that corner. It's not really marked. It's got that notch there, which usually indicates. And of course there's the socket up here that'll have a cable around to the socket here that is the where the data signals, etc., are brought across so the two can play together. So this ought to produce kind of a really nice little mini IMSAI system. So, I'm kind of psyched to move forward on this. And I don't know the gentleman's name, Tom, somebody online has actually built up this combination and made a mini front panel for it. And his machine looks amazing, and that's what inspired me to go dig the parts out and see if I could finish this build. So this is kind of where we are. There's my introduction to what we're going to do. As I always do, I will go off and create some better documentation to build against. I'd like to get the resistor and capacitor values and everything in place. I will do that. We begin with the resistors. I've gone ahead and created this sheet and have marked all the discrete component values on it to make it a little bit easier to do. So there is one 470 ohm. They're calling for half watt. I don't think I have a 470 half watt. Isn't that wonderful? Okay. 4.7K. So I've got some 4.7Ks. Yep. Need 10 of them. 2, 4, 6, there's 8. 10. It's going to be interesting without silk screen on that board to assemble it, but I guess that's how the original board was shipped. So I'm not sure how consistent the lead spacing is. It looks like there's larger holes. Well, the vias seem to be the same size as the... It's going to be interesting because the picture is really pretty lousy. Let's see if I can get this thing together and have it work. So, let's see, 4.7Ks. There's one right there, and boy, that lead spacing is really, really wide. Looks like about the second one in. I definitely need to find my better glasses. They are at the moment buried over here. Is it this pair? So, of course, now I can't see the printout here. So 4.7K. 4.7K there with R18. I think it's almost going to be, I hate to say it, easier to do these one at a time. There's a diode marked right there. Maybe the diode's there, and the resistor's there. Yeah, that's the way it looks. The component holes are slightly larger. Okay. I probably should have taken a picture of the board and marked the components on the board, on the photo of the board, but I didn't do that. Oh, that spacing's too big. Okay, that's a pain. Why was that too big? This must have been really challenging back in the day. Although I do remember assembling small kits that didn't have silk screen. 1K, 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 1K. And there's 8 of them up along the top up here. Sorry, I'm probably doing a big chunk of this off camera. Apologies. See the orientation of the one I've got in is tolerance band up. Well, I bent those in very different places. It's not going to look perfect. how square that one is. I'll rebend it. Of course, the 8080 requires, I believe, plus and minus 5 and plus 12, if I remember right. And this is using a combination of a Zener for the minus 5, a little 3-pin regulator for the plus 12, and a 7805 for the plus 5, which is interesting. Looks pretty standard. It's got an 18 megahertz clock, or crystal that gets down to the 2-phase. Is that the same one I've been using? Yes. This one got bent way off center. Don't expect perfection here, but I do want it to at least look like I tried. And I'm awfully quiet. Apologies, it's Memorial Day here, which is why it's rainy out after 3 relatively nice days. And 1K, there's a bunch of 1K. 1K are 1 through 13. We'll start with those. 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. Great, straight to the floor. Which means it'll never be seen again. We know how it works. And of course, I don't see it lying here. This basically, we know the floor is a black hole. So all 8 of those down there are 1K. What the heck? Why did that go off the rails like that? Damn it. just not having much luck here. Five, six. There should be another one here. Did it shoot off someplace? I heard. Yeah, clear over there. One more. One, and again, these weren't centered super well. Guessing the original board wasn't solder masked. Assuming this is close to that original layout, I believe it's actually very accurate to it. Even without solder mask, looks like it would have been a pretty easy board to assemble. There's not a lot of tight spacing any place. I mean, the IC pins are what they are. I will socket, even though the manual has you directly soldering in the ICs, partly because the chips I'll be pulling from tend to be pulls, so I don't always know that they're working. I think it's going to be a decent looking board. Come on, let me flip you over. Yeah, the lack of silk screen is interesting. It's been a long time. Lead was a little bit long. So that's those. There are 5 more 1Ks down here. I was actually using the proper tool, the resistors would be centered automatically. But I don't know where the right one is. There should be 3 and 2. I've been looking for a new project since the Altair build, although I'm still playing with it a lot. I just upgraded the FTC Plus software in it, which brings a little bit of new capability, including 8 megabyte floppy images, on the serial floppy emulation, which is kind of cool. I've spent a bunch of time trying to get that machine to run with the Ithaca Audio Z80 card, and the fact that it just doesn't generate the exact match of the status symbols or the status signals onto the 8080 bus, just make it difficult. So where else are there 1K? There and there. There's 2 there. Wow. It's just my day for shooting components around the lab. So tolerance band to the right to match that one. And it's got to be these 2 spots. How did I get that so off center? I don't mean a little tiny bit off center. And now it's kind of off center the other way. Oh well. These are nice, fresh, new resistors. Both the solder pads and the resistors are taking solder very well, which is really nice. So there's 2 1K there. There's a single 1K up here. Now that I've started to put these on, kind of where they go, actually does jump out visually fairly well. So that's the 1K there. We don't have the half watt one that's for there. He's in. We've got those 2. We've got that one. I think that's all the resistors, minus the one I don't have in stock. So I need to go ahead and add the final 2 resistors. One of them I didn't get labeled on the sheet here. It's a 1K ohm. It goes in here. I don't remember which lead spacing I was using. I think it was the narrowest one. It was. So let's get that 1K ohm resistor in place. And it looks like it goes right here. Final resistor is a power resistor, and it's in the minus 5 volt power rail for the 8080 processor. And there's a power resistor that goes up here that they call for 470 ohm, And the closest I have here is a 510 ohm. And what's that? 430 ohm. If I go with the smaller resistor, there'll be more current flow in the regulator. It'll generate more heat. If I go with the larger resistor, there'll be less current flow, which is good. It'll generate less heat. But it needs to be able to provide enough current for the 8080 to run reliably. I suspect this 510 ohm as a substitution in here will be absolutely fine. And it'll run a little cooler with it in place there. How close are those leads to being usable? These leads are very corroded. Of course, one of the dogs is excited down there. So the lead spacing that was on it fits in well. There's a lot of corrosion on these leads just from sitting over time. I don't see a little piece of sandpaper here. The flux will probably get through that, but I'm not super thrilled with it. So I'm just going to try to knock some of that corrosion off and get some shiny lead. And I'm just using kind of that looks a little better. The serrated needle nose here, since it's what I happen to have laying here, to just kind of try to rub some of that off. Don't want to take too much material off, but I do want to get a good solder joint. It's a little bit cleaner. I also want to mount this so it's not tied up against the board. I actually want some air gap below it. What that'll do is increase airflow around the resistor. They only called for a 1/2 watt here, and what I'm putting in is much larger than that, but it's what I had. I don't expect the resistor to get particularly warm. Large copper pour here, which is going to be interesting to heat up, although the JVC just no problem. I think that's a good substitution. Like I say, it's what I had in stock. I got the tolerance band opposite everybody else because I wasn't paying attention. But he's in there already. I'm just going to leave him there. So I think that completes all the resistors. We've got a 78 M12 here for plus 12 volt regulation. There's a Zener. An instruction note on the picture from the manual here is where they show this Zener mounted is incorrect. It shows it kind of right here, and it's actually on these two pads out here. And if you look at where it's drawn, the traces make no sense. There's plus 12 rugged coming into the Zener. And what there needs to be is the minus 15 volt rail comes up around to the dropper resistor, and then it connects up to the Zener. And the Zener is actually attached, like I say, out here. The Zener is these holes out here. It's kind of implied it's that trace to ground. I've corrected that in my updated drawing, which I didn't print out here. I've added the label for that resistor. But I do think that gets us all the resistors. Apologies for the noise outside. The arborists are here taking out trees in the complex I live in. So we've got our bank of 1K, a single 1K, 4 1K and 4 1K, 3 and 2, single 4.7, 1K, 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 4.7K, and the 510 ohm I put in here. So I think that's good for the resistors. I think they're all in. So with that, I'll call the resistors complete. Let me put this other power resistor away. Just get it back into the box of power resistors. Sorry for the loud clicks. I will tame those down in the edit. hopefully. Going to call that done for the resistors. So I think this completes the resistor stage of the build. We'll move on to probably sockets next.